Welcome to this rigorous scientific lecture on using artificial intelligence to design a minimum viable product that is both simple and compelling. Over the next 15 minutes, we'll explore a systematic approach grounded in data-driven principles. Let's start with our central hypothesis. The probability that a product succeeds is directly proportional to how well it solves one specific user job, multiplied by the efficiency of the feedback loop we establish. We can express this as probability of success is proportional to J, the job solution quality, times F, the feedback loop efficiency. Here, J represents job to be done clarity, scaled from 0 to 1. 0 means no job identified, 1 means perfect problem solution fit. F represents feedback cycles per week. The faster we iterate, the higher our learning rate and probability of convergence to product market fit. Now, you might ask, why should we treat MVP design as a scientific process? The answer lies in reducing uncertainty systematically. Let me pose a question. What is the primary source of startup failure? According to CB Insight's analysis of over 400 failed startups, 42% failed due to no market need. 42%. This is not a random walk. This is a systematic error in hypothesis testing. We build products nobody wants. This is where artificial intelligence becomes invaluable. AI excels at pattern recognition across massive datasets that humans cannot process efficiently. I can analyze user interviews, survey data, behavioral analytics, and customer support tickets to identify patterns that reveal the core job to be done. Step 1 in our framework. Define one core user job. Not 3 jobs, not 5 jobs. 1. This is critical for achieving focus and measurable outcomes. What exactly is the job to be done? It's the progress a customer wants to make in a particular circumstance. It's not a feature, not a product. It's an outcome. Let's examine Uber as a concrete example. What is Uber's core job to be done? The core job is get from point A to point B reliably with a wait time under 10 minutes. Notice the specificity, not just transportation. Reliable transportation with a time constraint. It's not provide affordable rides. That's secondary. The job is immediacy and reliability. This distinction is scientifically important. It's also not offer flexible driving opportunities. That's the driver side. We focus on one user segment for our MVP. Now, how do we use AI to validate this job hypothesis? We apply natural language processing to thousands of user statements. We feed AI interview transcripts. It performs sentiment analysis, extracts key phrases, and clusters similar pain points using unsupervised learning. We calculate relevance as mentions of the job divided by total user statements. If this ratio exceeds 20%, we have statistical significance. If relevance is greater than 0.20, the job is statistically significant at the 95% confidence level for sample sizes above 30 users. Step 2. Design one core feature that directly addresses this job. This is where most founders fail. They build feature sets instead of focusing ruthlessly on one. The feature must map directly to the job with minimal cognitive load. We can quantify this using information theory. Simplicity equals 1 divided by steps times decisions. Fewer steps and decisions mean higher simplicity and better user experience. Consider Instagram's original MVP. What was the one core feature? The core feature was apply a filter to a photo with 1 click, then share to Facebook with 1 click. 2 steps total. That's it. The job to be done was make my ordinary photos look professional instantly. The feature delivered exactly that outcome. Instagram initially had no messaging, no stories, no reels. Those came later after proving the core hypothesis. This is scientific discipline. How can I help design this one feature? Through generative modeling and reinforcement learning from user interaction data. I can run thousands of UI variations simultaneously using multi-armed bandit algorithms. It identifies which design maximizes task completion rate. We measure conversion as users completing the job divided by users attempting the job. Our target is above 70% for a compelling MVP. Let's do a back-of-envelope calculation. How complex should our feature be? Development time grows exponentially with feature count. If n is the number of features, Time is approximately 2 to the power of n weeks. For one feature, 2 weeks. This is our target for MVP. For 3 features, 8 weeks. 4 times longer. We've now increased our risk by 4x before getting user feedback. For 5 features, 32 weeks. This is 7 months. By this time, market conditions may have shifted entirely. This is why focus matters scientifically. Step 3. Define activation metrics. Activation is the moment a user experiences the core value of your product for the first time. Here's an important question. What counts as activation? This is not arbitrary. It must correlate with long-term retention. Activation equals the first instance of job completion. For Uber, it's completing your first ride. For Instagram, it's posting your first filtered photo. We need to quantify the aha moment. This is when the user realizes the product solves their job better than alternatives. TAHA equals time to first value. Research shows this must occur within 5 minutes for consumer products, or we lose 80% of users. If activation takes longer than 5 minutes, 80% of users abandon the product. This is empirically verified across hundreds of products. I can dramatically optimize activation rates through predictive modeling and personalization. Machine learning models can predict which users are likely to activate based on their first 30 seconds of behavior. We can then intervene proactively. Probability of activation is a function of clicks, time spent, and action sequence. A gradient boosting model can predict this with 85% accuracy. When the model detects a user is at risk of not activating, it triggers just-in-time guidance. This increases activation rates by 20 to 40%. Step 4. Track retention rigorously. Retention is the ultimate metric. It proves that your product solves a recurring job, not a one-time novelty. Let's examine the retention curve. This is the percentage of users still active after n days. The x-axis represents days since sign-up. The y-axis represents percentage of users still active. There are 3 types of retention curves, and they tell us everything about product-market fit. Type 1. Declining asymptotically to 0. This means no product-market fit. Users try the product once and never return. Type 2. Declining but flattening above 20%. This indicates potential product-market fit. A core group finds recurring value. Type 3. Retention actually increases over time. This is rare, but indicates extremely strong product-market fit. The product becomes more valuable with use. The gold standard for consumer products is 40% day 30 retention. If you achieve this, you likely have product-market fit. AI enables sophisticated cohort analysis that would be impossible manually. Machine learning can segment users into micro-cohorts based on hundreds of behavioral features. This reveals which user types retain best. We identify the best cohort as argmax of day 30 retention across all cohorts. This tells us our ideal customer profile. Let's calculate a retention rate with real numbers. Suppose we acquire 1,000 users in week 1. Week 1, 1,000 users sign up. Week 2, 400 return. That's 40% week 1 retention. Week 3, 280 return. That's 70% of week 2 users, or 28% overall. Week 4, 238 return. That's 85% of week 3, or 23.8% overall. Notice the curve is flattening. The rate of decline is decreasing. This suggests we're approaching a stable retention plateau. Now let's discuss setting up the feedback loop. This is where I truly accelerates learning. Traditional feedback relies on surveys and interviews. These are valuable but slow. You might get feedback once per week at best. AI-powered feedback uses behavioral signals in real time. Every click, every hesitation, every abandonment is data. The AI feedback loop operates on a 24 to 48-hour cycle. User action triggers AI analysis, which informs product updates, which are deployed back to users immediately. We can quantify our learning rate scientifically. Learning equals experiments per unit time multiplied by insights per experiment. AI increases both terms. AI enables 10 times more experiments through automation and 3 times more insights through pattern recognition. That's a 30x learning advantage. Let's examine Netflix as a real-world example of AI-driven MVP optimization. The job to be done is, help me find something to watch in under 90 seconds. This is the core value proposition. One key feature is personalized thumbnail images. Netflix shows different thumbnails to different users for the same content. For the same movie, user A sees an action-oriented thumbnail, user B sees a romance-oriented thumbnail, and user C sees a comedy-oriented thumbnail. Netflix's AI tests millions of thumbnail combinations per day, learning which images lead to viewing and completion. The impact is plus 30% engagement. That's massive, and it's measurable, repeatable, and scientifically rigorous. Let's calculate the expected value of building an MVP using our framework versus building a full product. Expected value of MVP equals probability of success times value minus cost. Assume probability of MVP success is 15% and cost is $10,000. Probability of full product success is 5%. Because we have no user feedback, cost is $100,000. Assume if either succeeds, the value is $1 million. Expected value of MVP is 0.15 times 1 million minus 10,000 equals $140,000. Expected value of full product is 0.05 times 1 million minus 100,000 equals negative $50,000. The MVP approach has 14 times better expected value. This is not opinion. This is mathematics. Let me highlight common pitfalls that cause MVP failures, even with AI assistance. Pitfall 1. Choosing vanity metrics over real metrics. Signups are vanity. Activation and retention are real. Pitfall 2. Building features before validating the job. This is building in a vacuum. The job must be validated first with real user research. Pitfall 3. Ignoring negative feedback from AI signals. If the data shows users are not activating, do not rationalize it away. Pivot immediately. Pitfall 4. Over-engineering the first version. Perfection is the enemy of learning. Ship the minimum that validates your hypothesis. Let's formalize this as a scientific method for MVP development. Step 1. Formulate a hypothesis. Define the job to be done and the one feature that addresses it. Step 2. Conduct an experiment. Build the MVP and launch it to real users, not beta testers or friends. Step 3. Measure results. Track activation rate, day 1 retention, day 7 retention, and day 30 retention. Step 4. Analyze data. Use AI to identify patterns in which users activate, which cohorts retain, and why others churn. Step 5. Iterate. Refine the feature or pivot to a different job based on evidence, not intuition. Let me share a final case study that exemplifies this approach. Dropbox is a masterclass in MVP design. The job to be done was, sync my files across devices without thinking about it. Notice the without thinking part. Ease is part of the job. The one feature was, a folder that auto-syncs. That's it. Drop files in, they appear everywhere. No buttons, no settings, no complexity. For initial validation, Drew Houston didn't build the full product. He made a 3-minute video showing how it would work. Result: 75,000 signups overnight. This validated the job before writing production code. That's scientific rigor. Dropbox measured intent by requiring email signup. This separated genuine interest from casual browsing. Intent is measurable commitment. Let's quantify what good metrics look like for your MVP in the first 30 days. Activation rate should exceed 25%. That means 1 in 4 users who sign up complete the core job at least once. Day 1 retention should exceed 40%. That means 4 in 10 users return the next day. Day 7 retention should exceed 20%. 2 in 10 users are still active after 1 week. Day 30 retention should exceed 10%. 1 in 10 users remains active after 1 month. If you hit these thresholds, you have a foundation for growth. A. I can forecast long-term retention from early behavioral signals, accelerating decision-making. Machine learning models can predict day 30 retention from day 3 behavior with 70% accuracy. This means we know our trajectory in 3 days, not 30. Time saved is 27 days per iteration. Over 10 iterations, that's 270 days, or 9 months. This is a massive competitive advantage. Let me summarize our rigorous framework for AI-driven MVP design. 1. Define one core user job with measurable outcomes. Use AI to analyze user research and validate the job statistically. 2. Build one feature that maps directly to that job. Maximize simplicity. Target 2-week build time. 3. Track activation as first job completion within 5 minutes. Aim for activation rate above 25%. 4. Measure retention at day 1, day 7, and day 30. Target a flattening curve above 10% day 30 retention. 5. Use AI to analyze behavioral patterns and iterate every 48 hours. This creates a 30x learning advantage over traditional methods. Let's close with the mathematics of iteration, because this is what separates winners from losers. Probability of success after n tries equals 1 minus the quantity 1 minus p to the power of n. If each iteration has a 10% chance of success, after 10 iterations, your cumulative probability is 65%. After 20 iterations, it's 88%. This is why iteration velocity matters more than initial idea quality. Final question. How many iterations do successful startups need before finding product-market fit? The answer from analyzing unicorn startups is 7 to 12 major iterations. This is not luck. This is disciplined experimentation. AI accelerates this timeline from 12 months to 4 months for 10 iterations by automating analysis and enabling real-time optimization. In conclusion, designing a compelling MVP is not an art. It is a science. Success equals clear job definition, times simple feature, times fast feedback loops, times AI-powered analysis. Every assumption must be tested with real user behavior, not surveys or opinions. Behavior is truth. The faster you iterate, the higher your probability of success. This is mathematically provable and empirically verified. Use AI not to replace thinking, but to accelerate learning. The human defines the job. The AI optimizes the solution.